So this is our Plant IV project. My name is Trevor Casper. Also part of this group are Chelsea Anderson and Gabriel Polson. So for our project, many of us have killed houseplants before, either because we water them too much or we forget to water them at all, which is normally what happens for me. The purpose of this project is to create a closed-loop control system to water a plant without us having to think about it. We know that the only real input that we need to control for this system is water. Water is removed from the system naturally by the plants or just by evaporation or drainage through the soil. This control system is designed to work over a long period of time. We need to continuously measure the voltage response from a moisture sensor over the course of days or weeks in order to effectively see change in the moisture content of the soil. This presents kind of a unique situation and was difficult to do, but we found a kit designed for this purpose on Amazon.
So this is the entire system and its proper hookup in order to make it work correctly. Now throughout the process we're going to be trying to communicate between the pump and the soil probe so that the pump can deliver the correct amount of water to our growing plant that we hope is not dead yet. So going from right to left, I will explain each of these parts and their individual functions. So the soil probe is simply responsible for sensing voltage. And for the purposes of this project, we read voltages between 0 and 1 volts. Now that is connected up to what we call a potentiator, which is responsible for actually reading those voltages and storing them as variables that we can use later on. Right here in the middle, not shown here in the diagram, is where we actually hook everything up to the Arduino, which then hooks it up to the trigger right here. Now the trigger is very special because it's what's directly connected to the pump. When we read voltage from the soil probe to the potentiator, we're using analog, because it's continually reading data points. But over here, from the potentiator to the pump, we're reading digital signals, which means it's only happening in discrete concrete steps. And the pump, we only want it to either be on or we want it to be off. And this, of course, right here is just the battery pack which powers the entire system and the Arduino. This is the overview of what it looks like in real life. Here again is my soil probe. Here's our pump in a little cup of water. Here is the battery pack on top of the Book of Mormon, signaling that scripture power is the best type of power. And here's our little Arduino. So that is our setup. And now we will explain to you how our code and entire system works from the computer.
Alright, so now the next step is obviously to start testing the code. So originally we started testing where we just stuck the sensor in the soil and then added water via code, and that gave us some negative voltages, and I thought that was wrong, so I just cut all that data out and we didn't use it. But in our second attempt, we realized that when we were manually transferring it between air, water, and soil, that air had a voltage of 0.9, water had a voltage of 0.1, and soil had something in between. So really, we did need to keep that. In this first piece of code, we have all of our imports, all these important things. Here we're able to connect to the Arduino and read things and send things. And then in this last loop, originally we started with, hey, you can turn on the pump here and then turn off the pump here. But we ended up taking that out entirely and just had it continually reading. And we were able to actually collect voltages and create graphs. So here we started with our FOPDT model, and we came up with these parameters. This data set is for air and then soil and then air again. But right before this air point, we actually were in water, so that's why it has that weird dip and it isn't quite as good a fit as it could have been. Okay, so we have our PID controller and our cycles, and we decided to use a P-only controller because when you input water into your system, it actually has a huge overshoot, and we can't actually effectively take out water, so our error is really big, and we can't effectively use an integral term. So we decided to just use a P controller, and that ended up working really well. So we start out with the pumps always off, because our operating parameter is always 0. But then if our PID says that we have a negative error, so like our U is equal to a negative number, then that means that our 0.38 set point minus something larger than 0.38, which means that it's too dry, is happening, and so then we can turn on our pump. So then our operating parameter would be 1. And because we have a pump that just turns on or off, we have to have just 0 or 1, and we can't do anything that's like in between those values. And then we're able to say, hey, if our pump is off, you can read less values less often because it's not as important, and it takes a really, really long time for our soil to actually dry out to a place where it needs to actually turn on and put in more water. So that ended up working pretty well, and we're pretty grateful for it. And this is the overall system again. And as you can see, this is where I input my water and I sense it, and here's the Arduino, and it works great, and I was really happy with this closed loop system. So thank you for listening.